I am not Mr. Kabila, just to clarify. Bring it in. Bring it in. So let's talk about tomorrow before we dive into today. Tomorrow, you have a guest teacher, right? I am gone. I took personal day. Sorry, I love you, but I have a lot to get done before the weekend happens. If I haven't told you guys, we're putting on a giant event, and I am one of the people in charge of it, so we have a bunch of stuff to set up. DJ Hudcap will be there, but actually my older brother, who doesn't really have an official DJ name, but he actually is a professional DJ, like as a side job. He's DJing the event. I have to set it all up. So DJ Hudcap has to do the hard work, and then I don't even get to do the fun work. But I will. DJ Hudcap will get to DJ, the next canteen and everything. And actually, we're going to set up music for the fall cookout too. Go ahead. No, not this weekend, but the next one that we have. I have it in my planner or whatever. But if you can't read the comic, it says, if I've got 5 oranges and you take away 2, and then the student says, wouldn't that be stealing, miss? So, again, just razzing about subtraction. But, really, today, we are not going to use expression mats. Really? We are not going to use algebra tiles. We're not going to use any of that. All you need is your graph paper and pencil. Okay? So are we ready to go? You had your hand up for a while.
You just brought up the canteen. I was just wondering, if there was a canteen at, Kilburn, we could
talked about this.
Stop. No. A kid that is homeschool, would be McCord.
Yeah.
Can you still go to that?
I do not think so. It has to be your neighborhood school. Unless they allow guests. If it's a canteen where they're allowing people to bring guests, then that's more open. But if it's a closed school canteen, then I think you have to actually be one of those students. You would be on that sports team. You know what I mean? If you played a sport. Audrey?
Okay. So don't worry, say Alina will not subtract your taste buds with the turd. It's not going to happen.
But that would be adding negative. You wouldn't be taking anything away. You'd be adding a negative flavor. Well, I'm not the one who brought it up. All right. And stealing. 263. Please write down 3x minus the quantity of. We need to start talking about how math is written.
Really?
And how it's said when it's written in a certain way. So when you see parentheses, the way that we speak that. Go ahead. This is 3x minus the quantity of 2 minus x. Yeah. And you take a pause, plus 1. And sometimes people even say end parentheses if they want to be really particular. Because the reason we have to be so formalized about where is the parentheses starting and ending, that impacts what's going to be positive and negative, right? Because anything inside the parentheses right now is on the bottom of our expression mat, and we need to bring it up, right? We need to bring it across that center line. So you guys take a moment, try to simplify the left side, and compare it to the right side. So you're simplifying both for just A. You can move on to B if you get done, but for just A, we want to be able to put one of those inequality symbols in.
Wait, just the left side?
Left side versus right side, right? Which is greater, left side versus right side? Right side's easier to simplify, so there's not as much to do on the right side. But you want to get the left side simplified and then get the right side simplified. By the way, for those of you looking for a header, your header could just be recording work. That's what we're doing today, is recording work. We're just recording work.
Ha! Oh my God, it's the same thing. Yes. Why are you understanding?
Did everyone? Sorry, this is the wrong slide. Everyone get the homework? It's over on the right board. Tomorrow's homework, if you want to go ahead and fill it in, or later or whenever, is just the chapter 2 closure.
I did the problem,
Yes.
and I don't think it's possible able to tell which is greater.
Say more.
Basically, the end result of the left side is 2x plus 3. The end result of the right side is 4x minus 1. We don't know the value of x, and we aren't given enough information.
Interesting. So real quick, let's look at what we did here. So when we bring those values up across that middle line, right, when we take them out of the opposite world, how we notate that mathematically, and what I really encourage you to do, and this isn't right versus wrong, right? I can't count your question wrong because of this, but I really encourage, draw the arrows from the opposite symbol or subtraction or whatever you want to call that. I don't care what you call it, but draw an arrow to each value in the parentheses saying, oh yeah, we got to flip it. Right? We got to flip that tile as we bring it across. So this becomes 3x plus negative 2, or you could just say minus 2 if you want to, plus x plus 1. Versus, hey, we're going to move on, right? Like we had our fun, we had our fight, but like we're going to move on. We're going to quit wasting time with that. I don't care what you write. I made my stance known. Subtraction is an evil thing created by man. It's the opposite of addition. It doesn't really exist. But whatever you choose to do is your prerogative. Just like if you choose to walk in front of a bus, I can't stop you. Now, subtraction is not as dangerous. Group-like terms. So 4x, Henry said, is the result of our 3x and our x. And then negative 2 and 1 gives me a negative 1, or you could do minus 1, whatever you want, but I like addition. Ooh, see, be careful. Guys, what we're emphasizing today is writing down the work as we go. So please don't wait for me. Please try it on your own and then catch any mistakes that you make. This is still versus, well, like terms here, negative 5 and positive 4 gives me a negative 1. And then I still have a 4x. No, you said we couldn't figure out which one was bigger. I agree with you, but there's more to it than that. Simon?
The reason we can't figure out which is bigger is because they both end up with an equal result.
They end up with an equal quantity because the same amount of variables, 4x and 4x, and the same amount of constants, which by the, I don't know if we've used that vocab much yet this year. Anything without a variable is a constant. So our constants here, negative 1 and negative 1, there we go.
But if you want to feel better about yourself, you write a greater than or equal to or a less than or equal to.
But we don't. Because both of those at the same time is equal. Because neither of them could be larger or smaller. Because the x on that side and the x on this side have to be the same thing. Right? Now, the x in the next problem could be a different x, but this problem using x has to be the same thing. We don't need to go any further. So I'm gonna let you do it, but for the fact of mathematicians are efficient. Hey there, please don't make it any worse. For the fact that mathematicians are efficient, we're done. Right? This problem's done. All it asks us to do is compare. Now, when you mean can you simplify, you're not actually simplifying. You're just continuing to do algebra. But what would you do next? You don't even have to cut it. I'm trying to move fast, but okay. Do it in red if you're doing something on both sides. Or what are you doing? I don't know what you're doing.
Red. That guy? He's gone.
Yeah, but that's not how we write algebra.
He died.
So while I agree with Bear, you cannot write algebra like this. Okay? That's how we drew things on the expression mat. We're not doing that anymore. Right? We are now operating at the 8th grade level of we're doing algebra. What Bear's talking about, we would write like a +1 and a +1, which would remove the negative ones. And then we could minus 4x and minus 4x, which would remove those. And you get 0 on both sides.
Yep.
Audrey?
I would say do the 4x first if you were only going to do one, because then you actually know the answer to both of them. I agree.
Sure. Yeah, it's up to you guys. Really, though, we're done right here. we are like we found out the left side's equal to the right side. We walk away. Like you don't need to keep going. Sure. All right. Do B, which is greater. Now we have squared values. Uh-oh. I am recording.
I said I forgot you still were.
Oh, well, I'm always recording.
Hey, you said to remind you you're not, so I don't think you always are. But,
Thank you.
So you have less to look at.
whoa.
2x squared minus 2x plus 6 minus a negative. Yeah, sneeze at that. It's gross. Oh, do you need a tissue? Huh? Oh, what's up?
I just wanna know, is there like something that it's kind of weird, but it's something that so you know subtraction if you get to a negative number it moves it away from zero.
What direction? So we watched the video. If you take away bad guys, it's the same as
Adding negative values.
adding good guys, right? So we're talking like good guys, bad guys. Taking away bad guys.
What I'm saying is so if you I'm gonna say subtraction just for the sake
Yeah,
of
that's fine.
simplicity here, but
We use the word, just the operation I have an issue with.
okay, so if you subtract a positive number from a negative number, then it moves away from zero.
Yeah, moves further negative because you're taking
Now
away
if you subtract
positive.
a positive number, positive number, you move closer.
Depends.
Oh!
Because if you subtract a bigger positive number than what you started out with, you'll end up moving further away from zero. You'll move closer to it first, but then you'll keep going. Right? So this is where subtraction is really wrong.
Mr.
That's
Hudson.
why we don't really like subtraction.
No, but what I'm saying is there's something is an operation. There's a negative number.
Actually.
It'll add positive to it if you bring it closer to zero. It's positive.
Subtracting negative
It'll
does
move
that.
it closer to zero.
Yeah, so minus a negative is the same thing as adding positive. Subtracting positive is the same thing as adding negative, right? So I can move the symbols around.
Oh my god.
So minus a negative does the same thing as adding positive. Just replace it. Liam, I don't know why you're dancing like a child, but can we knock it off, please?
I got it. I suck it out. Like a lot.
If we flip those tiles that need flipped, the opposite of a negative 3x is 3x. The opposite of a 3 is 3. The opposite of a negative 2x squared is a positive 2x squared. The 5 comes down, the 2x comes down. This should be our first step.
Wouldn't it be negative?
We should not be combining, you're absolutely right, I forgot to write that. We should not be combining anything yet, for exactly that reason. There's a lot of opportunities to make a mistake here, right? I totally just made a mistake just because I can't talk and write at the same time very well. That's when I mainly goof up, when I'm trying to talk to you guys and write. And it's just my brain just can't do it all at the same time, right? Our brains are limited. So now I go and collect like terms. And when I used to do this, like I would use a highlighter or things as I was starting out. And I would highlight things that, like using the same color, right?
Like,
so maybe if I did this, I'd say, okay, this, and you can't really see the yellow here, that and that. So we get a positive x out of those, right? So this doesn't have anyone to join up with. I want green. So 2x squared, no one to play with. If I have 1x, do I need to write the 1?
Yeah.
No. If I have just
I don't
1x,
know
I can just write the x.
We don't have to.
Over here, like terms, the constants, right? So negative 3 and 5. What do I get when I put those together? 2. But remember, we're going to put our values in the better order. So we're going to start with 2x squared. And then 2x.
Oh my god, it's 2, 2, 2.
And then 2.
2, 2, 2.
What could we do here? I should really use cards, but I'll get. Okay, go ahead while I get the cards out. What could we do?
We can get rid of the 2x squared and 1x.
Ooh, only do one thing at a time. I agree. I agree, but only do one thing at a time. I even try to like slow my high school class down and get them to just do one thing at a time. So minus 2x squared minus 2x squared. And guys, what we're practicing today is how do we write this correctly? That's what we do. We show we're taking away 2x squared on both sides. Yeah, we're taking it away. I say it. It's okay. So now we have x and 6 and 2x and 2. Now, then you were about to go on and say, we can get rid of one of the x's also. So we subtract an x and subtract an x, which sometimes it's beneficial to put the 1 here because 2 minus, well, we got to think about it. Here's the trap door. Students will look at this, especially if they didn't write the 1. So say I just wrote minus x. What do you think the trap door there is? No, I can't really use cards for this. Charlie, what do you think the trap door is?
The trap door is they remove the x, but they do not remove the 2.
They do that. Right? This is 2 and an x, right? A 2 and an x. And they said take away the x, so I'm just left with the 2. No! This is 2 x's. This is why we did the tiles, right? This is 2 x tiles. I take away 1 x tile. We're left with 1 x tile, right? Because we had 2 x tiles, take away 1 x tile. Now, I've not ever had the opportunity to teach the Math 8 class, so maybe you won't fall in that trap door because you're all, too good to do that.
Totally.
But here's what we have now. 6 and x plus 2.
Now we have no idea. We can do
Yeah.
4.
We know what's up.
You subtract 2 to both sides.
Ooh. We could. Now, why are you doing that?
So you could get x.
To isolate the x.
I agree. And the other reason is just to group like terms. Right? Alina said, I have like terms, but they're on 2 different sides.
I never said that.
That's what you were thinking. We might have to have a parent-teacher conference, girl. This disrespect is getting a little out of hand. So, if, now be careful, if we were told the 2 sides were equal, why Alina just did that is because now we know what x is. But we don't know how these 2 sides compare, right? They asked us which is bigger. We don't know because we don't know what x is. Right, so if they were asking us which is bigger, I got my one side down to 4, my one side down to x, but I don't know what x is, so who knows? But then mathematics likes to say, and now, if you're told the left side is equal to the right side, and then we're able to say x is 4. Any questions on the algebra we did, the operations on both sides? The very last thing.
Yeah.
So if from the beginning, instead of them saying which is greater, I'm not on the pen right here, but instead of saying which is greater, if they said that this or was an equal to, if they said this side's equal to that side, then when we're over here, we would then know equal, 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 all the way down. And when I isolate x, I would then know, well, x is equal to 4. And I could actually go back up to the top, plug it in, and try it. So if we make x 4, the 2 sides are balanced. So wait a minute. We do know which side's bigger.
What?
Anyone want to be really bold? Bless you. Bless
Oh,
you.
I think I know.
Bless you.
This will involve an if.
So if x equals 4 was equivalent to 4, then that would mean x is 4, and that would mean that this is equivalent.
Okay. If
If it equals something higher than 4, then it would be that.
so, we can make 2 kind of arguably 3 statements here.
Ooh.
is what, and when you're up front, might as well
drop.
well, so, and I want to keep moving because actually we're taking too long for this question. But so what's the third statement we could make? If x
is less than 4, then it would go this way.
Yeah, then the left side would be bigger, right? So if x is 4, they're equal. If x is bigger than 4, right side's greater. If x is less than 4, left side's greater.
How do you rate that one thing?
You don't need, like, we don't need to. Really where we're headed with this is they will tell you they're equal. And then we're just solving equations. Yeah, so really where we're going is just getting used to solving equations.
I'm not ready. Really?
Yes, you are.
Yes, you are.
All right, we're going to skip part C there.
No.
What? You don't want some time to work on your homework?
No, I want to do those problems.
I want all the homework done.
I want to do those problems.
I'm terrified.
Debating which ones I really want to do. Let's, for 64 here, because I want to check if we can write these things down. Write down what we have to start, like exactly what we see to start, and then simplify it all the way through. Figure out if you're able to determine which one is bigger. And I even made it easier by showing you the red and blue versus just gray and not gray.
What? Wait,
You're writing down exactly what you see and then comparing the two sides. So I'll help you in a minute, but I want to give you guys a head start so you are doing it on your own. Write down exactly what you see before we move anything, before we do anything. Why do what? I don't. I mean, it's a school computer, so it's probably just on here.
Translation, it's very, very, very difficult.
7th grade classroom appropriate behavior. Oh, is that not the move that you wanted?
I mean, it was fine, but like, no.
I have to stand up for this, just so that I can see things.
I'm like 98% sure I screwed up.
There.
That's okay.
Can we simplify it if you want to? But not.
Oh, you can do as much as you want with this. Your goal is to be able to compare the left side and the right side. I was just writing down what I saw. I saw 1, I saw 3 negatives, and then I saw 2 negative x's. In the opposite world, I saw 3 and a negative x. So I could put plus a negative, but I know it will make other people happier if I just write it as subtraction.
No.
I'm going to copy it down here and start to
One
clean it up.
person in the room.
No, a bunch of you, because a lot of you won't let it die. Alina's just the only one bold enough to actually fight with me.
Oh, why do you care? I don't really care if Louise is mad.
Yeah, why do you guys care?
I'm just having a good time.
Don't it mess with the girls.
There, you need to very quickly learn that the rules for what boys and girls are allowed to do are very different.
Very, very different. Anyone else's pencil rubber? Yes.
So what I meant when we said write down exactly what you see, hey guys, I shouldn't have to be fighting with rubber pencils. Have you figured out which side is greater?
Yes.
Are we fully simplified? And I'm asking this more like hypothetically of, even if you're fully simplified, you should not be off task. I should not be wasting my effort having to stop rubber pencil. Like, come on, we're in 7th grade. You're in 8th grade math. You're literally in this class because you've been identified as a gifted learner. Like, if that hasn't been made clear to you, You're in this class because you're identified as a gifted learner, and the district is giving you services for that. Like, literally, this is special education. If no one's ever told you, like, for some reason that word has gotten a negative connotation, but you are in a special class because you're a year ahead in math. But my frustration that is growing more and more is the off-task behaviors. If you are a person that does the math faster, bring your book to class, like your textbook, and you can keep going. You can move on to the next question. But I'm not going to move on until I feel like people are ready. So if you're the first one done, guess what? You have to wait. That does not give you permission to get other people off task. And when you ask questions, is anyone else's pencil rubber? That's getting other people off task, which we talked about week 1 is one of our only Phoenix rules. You cannot negatively impact the education of you or others. Just to make that clear one more time. When we said you want to write exactly what you see, that's using the minus in front of a parenthesis that shows what's in the opposite land, right? Or in the negative area. Simon, you've had your hand up for a while.
First of all, why do you have parentheses in between the 3 minus x, and also can I simplify it?
Why do I have a parentheses here?
Yeah.
Because this 3 is in the opposite world, and that negative x is in the opposite world.
Okay.
So I actually have to flip them, right, which I haven't done yet, and that's why that negative is in front of them, and then why they're in parentheses, because both of them need to be flipped.
Can I simplify?
Sure, but I'm going to write it out up here because I'm going to show how we simplify. So you can go ahead and talk it through, but I got to do some writing.
So the way you simplify is you try, so when we're doing an algebraic expression, you get rid of all the parentheses you can, whether that involves multiplication if it's like terms, or addition if it's like terms. Just anything, if it's like terms, the parentheses, you can do it. But if it's not, you just have to get rid of them because you don't know what it's going to be.
Now be careful, it's not just to get rid of. If there's a negative in front of it, we have to apply that. So when getting rid of the parentheses, you have to look at what comes in front of it, or really what's directly attached to it. So if there was a 3 out here, that's directly attached. It multiplies into the parentheses. And I know this is going to screw with your brain because you're used to seeing the number in front that's going to multiply. But this is directly attached. There's a multiplication symbol between. That doesn't exist here. Okay, I just wrote that in here. I'm messing with the equation. But just because I wanted to pause Simon really quick and say, you just have to double check. Can I just get rid of the parentheses, or is there anything to do?
I'm confused.
So, Simon said, if I can't combine the things in the parentheses, I get rid of the parentheses, which is true. But to get rid of the parentheses, this negative that is in front of the parentheses has to be distributed, which that's vocab we're going to learn through the distributive property. It distributes and says the opposite of x is negative x. Right? The opposite of negative 2, when I bring these up and flip them, will be positive 2. Right? So I apply that over here, and actually I could go ahead and put these together because they're just constants that don't have anything else to do. So if I put those constants together, negative 1, a negative x, right, because the opposite of an x, and the opposite of negative 2, sorry, plus 2.
Oh, and so now you can, well, if you simplify the other green, you can add an x and then you're good.
So over here, you said add an x.
No, not yet. You have to combine like terms there first.
Okay, so negative 2, negative 3, negative 5. Right, I'm going to put that in parentheses just because it's negative. Negative 2x, positive x, what do we get?
Negative x.
Negative x.
And so then you just have to, but be sure to, so you can just have to add x on both sides so they stay equal.
Now hold up, I agree with you, but let me clean up this side really quick. Negative 1 and 2, I get a positive 1. So now Simon's telling me what to do to both sides. I change colors when we do that here. So Simon said add an x, add like a positive x, right? Which with a negative x destroys it, turns into 0.
And then all you're left with is -5 and 1, which makes it much easier to tell which one.
Which side's bigger?
1. But the -5 is more powerful.
Right. -5 carries more power, but the positive one is greater. Patrick? You want to go back through the whole, like you want to see it again?
Are the parentheses around the -5 necessary?
That's a really good question. Kind of. And I know that's a really bad answer. Negative numbers can be viewed as subtraction, right? Can be viewed as, but not when they start the problem. So to write -5 minus x is the same thing as what we have up here, technically. But this is not clean, according to mathematicians. They would at a minimum say put the -5 in parentheses because it's the beginning of your expression. But then we could say minus x, but still people don't really like that. So we normally end up saying plus a negative, and that's the cleaner way to write it. Or, and this is kind of unsimplifying, and guys, I know I'm over teaching, but Patrick asked a really good question. We could say, hey, what we have is actually the opposite of 5 and x, and that's how most people would write it. Instead of using 2 different negatives or 2 different minuses, they would say my left side involves a -5 and a -x. So what we have is -5 and x.
Whoa!
Henry.
No, but quite frankly, I don't see how writing unnecessary parentheses is efficient.
I hope that someday you'll come back to me and say, hey, I've actually realized why these parentheses are important, but I can't really sell you on that. I could sell you a snowblower, like when I used to work at Sears. I can sell that. I can't make you believe those parentheses are necessary. Like, I just can't.
But so I'll agree to disagree.
No, and that's totally fine. What I'm saying is, like, as you go through math, you may discover a moment when you're like, oh, that's why. But until you get there, I can't, like, get you there. So you can think they're unnecessary, and that's fine. That's seriously fine. I'm not, like, saying that sarcastically. If you don't put them in, that's okay. But if your work is really messy and I have to call you over and say, like, hey, explain this to me, just, like, no, that's why. Because I like those parentheses around negative numbers. It keeps things cleaner.
I just do that so that it doesn't look like one really big minus sign.
Yeah, especially if you have minus a negative, that quickly can look like one big minus sign.
Let's work on.
All right, so let's discuss what they do here, okay? To talk about what's necessary and what's not. Oh, yeah. You're always, you guys, bathroom water, you're always welcome. So if we compare left expression, right expression, who can, yeah, don't drink bathroom water. Who can tell me, actually, I said we were going to use, no, I lost the cards. I don't know why kids think that. It wouldn't taste like lemonade, all because it's yellow. All right, Alex Ashita. On the left side, what do they do between, hey, I'm not asking you to write anything down unless you want to. What do they do between step 1 and step 2? How do they have less things?
Subtract x squared from each side.
Ah, they subtracted x squared from each side. Does everyone, because I'm using random cards, does everyone now see how Alex recognized that? He's just like, well, what's not there? Right? What was there? That's not there now. Take a moment in your brain, look through the whole problem. What did they do in each step? Take a moment, no talking. Give me like 5 seconds. I'm going to throw it onto the other thing. Henry, can you tell me what they did between steps 2 and 3?
the plus sign to a minus sign and got rid of those parentheses.
Ah, so what? You're absolutely right. What we would say there then is, yeah, technically, I know I use that word a lot. They distributed.
Oh my god, how did I call it?
Distribute the negative.
Should I write this down?
You do not have to. We will go over one of these together. So this, what is the opposite of a negative? A positive, right? What is the opposite of positive 4? Negative 4, or take away 4, right? If you want to think about it like that. And the opposite of add 2x, take away 2x or minus 2x. Or negative 2x. All of the ways to say it.
You wrote Nez.
No, that's a G, but it's cursive. Yeah, you guys just don't know how to write in cursive. I'm sorry. You got the short form. No, you know how to sign your name. If I asked you to write a paper in cursive. Elena. Hey there. You know it's not appropriate to just like walk up to the board when we're going through and calling other people. Elena, between steps 3 and 4. So from here to here. What did they do? Huh? Yes.
Okay, so on the right we have, so they added like terms.
Ooh, combine like terms. So here we would say combine, comb the like terms. Because the word comb is the beginning of the word combine, right? To comb your hair, combine the terms. And then, Logan, what are we doing the last one? No, the other one. Yes, you. I know, but he's in the other class. But that's not what they did. What did they do from here to here? That happened on both sides. You can pass it to Hazel if you want. What changed on the left side? What's gone? Yeah, that's what they did. They got rid of 2x on both sides. So literally, get rid of the 2x, get rid of the 2x, because it's the same on both sides. Can I compare left to right now? Yeah. What symbol do I put in here? Greater than. Please make sure that you can actually say that. Everybody should have a 217. Unless you were absent yesterday, pull this out. 217. Unless you were absent yesterday. If you were absent yesterday and you need one, please stick the hand or come up here. Dude, I only make 2 extra copies. You're killing me. Taking the extra copies. You need another one too? Okay, well, why are you not moving? We're going to skip to 68. Yes, because I want to talk about a problem I've already had questions on. We're going to skip. Hey, so 67 is still one of your practice questions, but I want to talk about 68. Okay? I'm hoping that at this point we can clean up the problems, distribute the negatives, add like terms. Like that's what hopefully we got from today. But I want to talk about some properties here. So in mathematics, there are a couple really big, really important properties, and they're applied for all of the different operations. So there are 2 main names to our properties. There are the commutative properties and the associative properties. Yes. Now that we're not talking about that here right now. Sorry, not to discount anything. So yes, hopefully you guys already know about the distributive property, and I'll put that poster up. But that's what we were doing with the arrows, distributing a negative or a multiplication. We're splitting things up. That's distributive, right? I believe it was in this lesson. It's the next one. Who was I talking with about this yesterday? Do you remember where we found the commutative property? I lost the properties. Aha! All right. So guys, Back in 215. Back in 215, and you may have breezed through this. And you're probably going to want to write a little note to yourself. The commutative properties are a fancy way of saying move. Because to commute means to move. If somebody says they are a commuter, they have to move to get to work. Most people are commuters. If you're not a commuter, you work from home. So the commutative property of addition says 2 plus 3 is the same as 3 plus 2. I can move the order and it doesn't change the math. But is 3 minus 2 the same as 2 minus 3?
No.
No. Notice subtraction isn't up there. Is 2 times 3 the same as 3 times 2?
Yes.
Yes. But is 3 divided by 2 the same as 2 divided by 3?
Not at all.
No. So commutative properties only work for addition and multiplication. The associative properties, and this especially at the end of class is where I'm hoping, looking at you there, that we're all mature enough for me to teach you the thing that will help you remember this forever. The first 3 letters of this property. You don't need to say it out loud. You do not need to say it out loud. But if you think about what the first 3 letters of that would look like that's the bad word for butt. Right? It's the bad word for your butt. Butt cheeks. Right? The associative property, butt cheek property. You move the butt cheeks. And that's how you know it's the associative property. So what we're looking for would, hold up, would 1 plus 2 then plus 3 be the same as 1 plus 2 plus 3? Yes. Because it's all just adding. So they give you this example here. Multiplication, same thing. Would 1 times 2 then times 3 be the same? Yes, I can move the grouping and it stays the same. So technically what this means, to associate, means who you're grouped with, right? If I'm in an association, I'm grouped with those people. Associative property changes who you're grouped with. And identity gets back what you start with. The identity property gets back what you start with. Okay? What? Correct. That's why those properties work for both, right? That it is for addition and for multiplication. You're right. We're not arguing anything, and we're out of time, so we gotta go. Have a great day, guys.
Thank you.
Thank you. Stay out here until